Hi everybody. Okay, so this project, it's a magnetic field visualization project. Okay, so what it does, the Hall sensor, which is this one here, see the Hall sensor here. Okay, what it does, it measure the magnetic field strength and polarity. So if I check this other side, obviously it'll be on the south, which is negative, and it will be on the right side, which is north, positive. Okay, the center, it's a baseline and it's 0. This one, obviously it's not 0 now because the field is still there. All right. So this is the way it works. It works with a Hall sensor, as I said. Okay. All right, it was an experiment. Okay, so this is practically the way it works. It's a visualize the magnetic field on the positive side and on the negative side. Okay, so you can reset it to discharge. Okay, the base center, when it has no field, it'll be 0 practically, although you can see there is a bit of electrical noise. Okay, but I'm not going to do that now. So, and again, let's have a look at it again. There we are. It shows there was the south, and this is the north. Obviously I got a small magneto, so this is just to show you how to test or how to use your Hall sensor, which is it's an interesting program. I kind of like. You can put numbers if you want, voltage and electrical intensity, to see how it works. Yeah, so let's. Okay, it's practically the way it works. It's when you subtract the baseline initialize calibration value, calculate the field strength is the absolute value, and obviously it's going to determine the polarity if it's positive, which is the north, or negative, which in this case would be the south. Okay, so the visualizer will be there. And a field which is 253, okay, or up to 255, but set it to 53. It's a field strength value top left. There we are, that one there. Okay. Let's try again. No, this is flat. So this gives you an idea. And also you can see that there is an LED here, which goes green on the positive side. I could add another LED on pin number 5, but I thought if you want to do that, you don't have an LED on board, it's fine. But I like to use one on board. but it only takes the north. It does not flash on the south. Other things you can do, you can have a 2 LED, one for the south, one for the north. So maybe a green for the north and a red for the south. Okay, what else we haven't spoke about? So the bar graph behavior, it's no field, it's an empty bar center line, okay? So no field, the center line here, okay? It's neutral, means the center. So obviously from the center to the left to the right, okay? So, and that's about it. It's you know, the technical details I will publish on your tube channel. Let us see the code quickly. Okay, so these are the codes. Okay. Your library, this is the graphic library for the OLED screen, and this is the Adafruit to initialize the OLED screen. Okay, this is the size of the OLED screen, the width and the height. So yeah. Then you have the whole sensor, which I put in pin 4, and I have an LED pin 5 if you want to use it. So, but I'm not using it. So, or the OLED screen is I2C, so it has 2 only data cable, except for positive and ground. It's only got 2 data cable, and it's a SDA pin 7 and SEL pin 6. Okay, this will initialize the OLED screen. All right, and this pin mod for a LED pin. You can put any color you like, and this is for the initialize the whole sensor pin. Okay, which it's here, and we gave the name LED pin 5 and a whole sensor pin 4, and yeah, there we are. Pin mode, it's a whole sensor pin input. We know that is in pin 4 or GPIO 4, and we know that this one is in GPIO 5, but it's not there at the moment. Okay, so this is all the code that will go through, obviously, to the display, the baseline and the bars. Okay, so as I said, I will display these codes on YouTube channel. Alright, and as I said, it uses a map to convert sensor value to pixel lengths. It has a constraint, keeps display with the bounds, and the OLED refresh rate is about 10 megahertz. I think I put it 10 megahertz. 10 millisecond delay. Okay. So practically it's a baseline noise reduction. Okay. Let me go back to so it's a whole sensor analog input, baseline calibration, it's a noise reduction, and center 0 display, clear polarity visualization. Okay, so you can see there's still a bit of electrical noise, but okay, that's the south. And the north. Okay, thank you very much, everybody. Have a good day, and please give me a thumbs up if you like it.